Okay, so this topic might be a little bit more familiar to some of you because you did your Area of Study 3 research assignment on it at the beginning of the year. This is all about crude oil and the process we use to separate crude oil. Now, technically, this isn't very useful for Unit 3-4, but I find it really interesting and I find it a lot more kind of relevant to real life for you, to make your hydrocarbons a little bit more important. So I want you to think about what is crude oil, where is it made, what do we use it for, why is it so important, why do they bang on about it in the news? So if you need to pause, have a chat, have a think, then you can come back to me in a second, and then you come back. And we're not going to write a paragraph on your whiteboards, but if you want to, or you want to express something to me, you can do that as well. So this is what the definition of crude oil is. So here is crude oil in this barrel here. This is my great illustration. So here is a crude oil barrel. And within that, there is a mixture of different lengthed hydrocarbons. Okay, so in here we've got some very long hydrocarbons, we've got really short hydrocarbons, some medium hydrocarbons, all different lengths. But it is a mixture. So you can't look at them, you can't pull one out, you can't just say, oh, that bit there looks like short chain, this bit over here looks like long chain. So that's what we get with crude oil. Then we're going to have a look at, in your notes, on page 2 of organic compounds, we're going to look at how it's formed. So hydrocarbons we find in crude oil, which is a non-renewable fuel. Okay, so this is a non-renewable fuel formed millions of years ago from dead animals and plants that fell to the bottom of the sea, were covered with sediment, and over time heat and pressure changed them into crude oil. Now the thing with crude oil is it normally forms underneath the ocean. Yeah, can you see here's the ocean? The oceans might dry up, the ocean sea levels might fall away, but ultimately the oil is trapped down here in this rock, and then you go here. Yeah, so then what we do is we get a big drill, we drill a giant hole down to where the oil is, and we pump it out. But the oil on itself isn't very useful. So I'm going to link to this YouTube video. And normally we do a bit of a card sort. And we might do one on Padlet, but I'm not sure at this stage, so we'll just see how we go. So here is the different types of things that we can use crude oil for, and the process that we use it for is called, it's a process in which we extract all of the different parts of crude oil, is called fractional distillation. Now it's all based on boiling point of different parts of the hydrocarbons. So do you remember how we said short hydrocarbons have really low boiling points? So these short hydrocarbons are these C1 to C4. Yeah, so they've got 1 carbon to 4 carbons. Now they're usually gases at room temperature. So this bit up here is quite cold at this. So this is a low boiling point. That makes sense. They are short, they have a low boiling point. As you go all the way down, you'll notice that the carbons get bigger and bigger and bigger. And the temperatures get higher, yeah, and higher all the way as you go down. So these ones here have a high boiling point. So we've got long chains down the bottom. They have a high boiling point. Why do they have a high boiling point? Because we have lots of dispersion forces, because those chains are so long, they're going to have a lot of interaction between them. And then at the top here, you've got very short chains, and they have very low boiling points. So you don't need to kind of extract them with this. So I just want you to watch this video and fill in this last little bit here that says crude oil is extracted from the ground via oil drilling. Then the crude oil is separated into fractions, hydrocarbons of similar size. So a fraction is like a part of the crude oil. So fractional distillation is separating it into all of its different parts. These fractions are separated based on their different decreasing as you go up boiling points. Each fraction has a different use due to the properties created by the differing size hydrocarbon. So this one up here, LPG, is the same gas that you get in your barbecue, We've got petrol in the middle here. That's what you put in your car. Then you've got things like diesel fuels, which you use for trains and like big trucks. Then you've got oils and waxes and polishes. And then right down the bottom here, you have that bitumen. So remember how I had a picture of the bitumen? Bitumen is a funny word. You might not have heard it before. B-I-T-U-M-E-N. It sounds like bitumen, but when you say it together, it kind of sounds like bitumen. So bitumen is what we use. It's a very thick, sticky, very viscous, lot of hydrocarbons. They usually got more than 70 carbon atoms in them, and it's really good for surfacing a road and evening it all out. So there's a big debate about when crude oil is going to run out, and it's very difficult to know that because we don't know how much oil there is left in the world. So we think that there are over 1 trillion, so 1 million barrels of crude oil in what we call our proven oil reserves. But at current rates, it might last us only 40 years, 50 years, depending on how much we use. Okay, so that is a really good kind of concept to think about when we do this. Now, there are some other problems with crude oil that you may have heard about before. So it's really, really useful, but it has several problems. So when you burn crude oil, when you burn gas, and when you burn petrol, and when you burn jet fuel, and you burn all these things, they produce gases and particles that contribute to global warming. In particular, a hydrocarbon has got lots of carbon in it, and when you burn that in oxygen, we're going to make a lot of carbon dioxide. Not a great thing. The other thing that you've got issues when we start to remove the oil from the ground. So as we are drilling the oil out from the ground, there can be spills. A lot of our oil refineries that sit on top of big platforms are out in the ocean. All it takes is like, a really rough sea, well, not just a really rough sea, but there might be an event, say a tsunami, and that would damage the oil drill, and it's still pumping up oil, and they'll pump up all of this oil. Now, the problem with that is oil floats. So when oil floats on the top of the ocean, it means that it cuts out sunlight from underneath. It means that those fish and the birds in particular get very affected by this. They land on the oil sticks to their feathers. They can't wash it off by going into water because oil and water repel. So it's very, very damaging to wildlife and the environment in general. And the last thing we've got is the fact that crude oil is often a source of military conflict. So large amounts of oil come from countries that aren't very stable or politically unstable. Not just stable in general, but politically unstable. And it can be a bit of a selling point, a bit of a sore point, and countries can often incite a bit of unrest between them based on the fact that they possess a lot of crude oil. So that's just a little bit of a summary about what crude oil is and what fractional distillation is.